Hello everyone, welcome back to FX021. In this chapter, I'm gonna teach you how to make the particle shockwave on our shield. Like the part here, how to make the particle shockwave, okay? So let's get started. So first thing first, we're gonna create our geo, name it particle shockwave, and let's dive inside. Create object merge here. We're gonna bring the point from our sparks. Okay, let's copy the points out here and paste that here. We want our shockwave generate on the same location as our sparks. Okay, and also we want to bring the shield here. Control C to copy it and create object merge. Control V to paste. Let's view it. Turn off the point display and name it to get shield. Name this one get point. Okay. Now what we're gonna do is exactly the same as we create our sparks. We want to create a geo here and copy that to the point and then make it explode. Okay, so we're gonna use a tube here and add a mountain node, connect, and use a copy to point. The left input is geo, the right is the point. And let's visualize this and template our shield here. The tube is too big, so let's reduce the height, turn off the point display, and increase columns and rows, maybe 100 here. Yeah, and 100 here. And it's too big, just decrease the radius scale here. Something like this, and the height, let's decrease the height. Okay, let me check. And now you can see that when we play the animation here, every hour for each tube they are like straight. Okay, which is pretty weird. It's because our point. Do you remember when I said when you use copy to point, the direction of the geo is based on the point normals, but we don't have normal on this point, so we're gonna create normal. So let's go back to the sparks and let's create normal for this point. So we gotta create normal here and connect here, connect and connect. Now this point will have normals, and let's go back to the particle shockwave. And now you can see it's laying on the surface of the shield now. Okay, let's grab the timeline. Yeah, and now we want to change the direction of the tube to z-axis. So now you can see looks like this, and we're gonna change the value of our mountain node. So let's find a frame here. Let's dive inside mountain node, change the amplitude and element size here. Something like that. Yeah, I think this may be good. Let's tweak some value here. Okay, I think this is good. Now we can create our velocity attribute for it. So use our old friend attribute wrangle and use at v equals at normal. Okay. The normal direction like this, and the velocity will be the same, so the particle will shoot everywhere from this direction. And now let's create a pop network here to emit our particles. Let's go inside pop network, change the burst to around 0.3, the variance here 0.15, and let's play it. Okay, something like this, and we can go outside, yeah, and see it. So what we want to do here is we want to have some collision behavior. So when the particle first spawn, we want to color them, have a different color here. Okay, so basically when the particle has collision on the surface, we want them to have a different color. So now let's do this. Turn off the point display here, and let's go inside, create a node called collision detect, pop collision detect, and the collision target we're gonna use the shield. So let's connect this to the second input of our pop network here, and dive inside. You can choose it to the second context geometry here, and the behavior here we just toggle the color to the red. Now let's play this again. Now you can see that when the particle first spawn, some particles are on the surface, so they are red, and others are white. So we can control the attribute here, so we can render it differently. Okay, and we can give it a group called heat, and turn off the color. So we now we have a group called heat now. I think now we have too much velocity, so let's reduce the velocity here to around 0.6, and add a pop drag here. Let's visualize this. Still too much, I think. Maybe increase the drag value here, and add a pop wing to give some randomness to it. Okay, just a little bit. Play it. Okay, now we want the particle slide on the surface, so we can use stop solver to bring the geo from the stop and rate these particles onto the shield. So let's copy the shield here, dive inside stop solver, use the object merge, paste it here, and use ray here. The first input is our particle simulation, the second one is our shield geo, and we can change it to minimum distance here, and let's play it. Now you can see the point sliding on the surface here. If we turn on our color here, you can see when the particle first spawn, it has whitish color, and then they all collide on the surface, or they are all red. So we can have different color on them. And now I think the particle amount is pretty low. We can increase the particle amount. So maybe this amount is good, I think. Let's play it. Maybe more, maybe this. Yeah, I think this is better. Let's go back to the sub level and create a file cache here to cache our particles, okay? Because we have lots of point here. So just like I said in the last chapter, we can change this to $OS, which is the name of our node. So it will be in our project path geo folder, and create a geo called file cache one, and the cache particle cache is called the file cache. $F means our frame, so file cache frame number 1, and that's our file format. Okay, let's call it particle shockwave cache, and yeah, let's save that to disk. And now check on the load from disk here, and you can visualize it. I think I forgot to turn off the color in the but it's okay. Now we can change the color of it. So because we create a group inside pop network in the pop collision detect, we name it to heat, so we can use a color node here. And the color node by default color all the point to the white, but we create a group, so let's find it. So we only want to color the heat group and turn that into blue. Okay, and you can see the point not in the group are white. So now let's color these points that are not in the heat group. Let's color them to maybe more bluish, more bright color, and you can use this means not in the heat group. Okay, so now you can see they have different colors. Let's turn off the shield to visualize better. So one particle first spawn, it has a brighter color, and then become darker and darker. Okay, that's how I achieve my effect here. As you can see here, when the particle first spawn, it has a more bright color when we add glow in the post, and then it the color become more darker and darker. Okay, now that we have our particle simulation on our shield, let's play it. You can see if we template our shield here, you can see these are perfectly on sliding on the shield. But we can also add some post process to these particle points even after they finish the simulation. So we can still use the mountain node to add some randomness to the point. So let's use a mountain node here just to add a little bit noise so that it's not perfectly a sphere shape here. So use the mountain node here, and you can already see it's already break up the pattern here, but it's a little bit too much for me, I think. So let's template our shield. Yeah, it's too much. So let's turn down the amplitude. If the amplitude is 0, it's perfectly on the surface. So let's increase a little bit. And element size, let's increase a little bit. Now you can see it's a subtle, but add more randomness to the on the surface of the particles. Okay, that's it for today for the particle series, and in next chapter I'm gonna talk about how to use the particle as source to emit our smoke. We got another layer of the shockwave, that is a smoke layer, which we can do in next chapter. Okay, and then we can render all these in Mantra or Kama or any other your favorite render engines. So see you in next chapter. And if you like the video, please hit the like and subscribe button. Yeah, bye bye.